This is geometry, day 7. We're proving a new proportion for similar triangles. What we're looking at is that if we have a side parallel to the side of the triangle, then we know that it will be splitting the two other sides proportionally. What we're trying to do is show that the A over the B is going to be equal to the C over the D. We're used to saying that the small triangle length of A over the big triangle length of A plus B. The small side turns into the big triangle. On this side, it would be the small triangle turning into the big triangle. That's our typical way that we like to write a proportion. We're going to start with this typical way, and we're going to try to convert that over to our A over B is C over D. We know that the two triangles, we have this smaller triangle and the larger triangle. We know that the two triangles are similar to each other because if the lines are parallel, then corresponding angles are congruent. We also have another set of corresponding angles here, and of course we have the reflexive because both the small triangle and the large triangle have the angle at the top. So we at least have angle-angle similarity. So to start out our proof, we're looking for our reasons. Now this reasons could be a little bit different than what we're used to. So often we start our proofs with given. I'm going to try this one to be a little bit different. Okay, we talked about how we have A over A plus B and C over C plus D. Okay, that is just a proportion of similar triangles. Usually we call it given, but in this case we'll call it proportion of similar triangles. Now we're taking that proportion and we're going to become this new line. How do we become this new line? What are we doing? How did that line become that line? By cross multiplying over, we are going to provide this one. So we can simply just call it cross multiplied. That's how we got that line 2. So now we're looking at line 3. Where does the line 3 come from? What are we doing to get to our line 3? What's different from line 2 to that produces line 3? We distribute through. You take the A times the C and the A times the D. The C times the A and the B. Distribution property. Okay, now we're looking at line 4. Where does line 4 come from? Line 4 looks a lot different than line 3. Line 3 had some pluses involved with it. Now we don't have any pluses. What happened?
Subtracted AC from both sides.
They both have the AC in line 3, but now we're going to take that down to no ACs for line 4. So, subtraction. Property of equality, POE. Subtract the same thing from both sides of an equal sign. That's called subtraction property of equality. Now we're sitting there with two parts that are multiplied to each other. And we look at line D. All we've done to get the A by itself is to divide the D to the other side. So that's called a division. POE. Dividing the same thing to both sides of an equal sign. And then the same thing, we're going to divide the other direction. We're going to take the B and bring it over here to this side. Divide B to both sides is going to be division. Property of equality. So now, what we've done, we have taken our typical proportion that's made of similar triangles. We've worked our way through regular math steps, and we've produced a new proportion. We haven't used this proportion before. At least we haven't written it from scratch. It's come up in a few problems. And where this comes from is if one side is parallel to a line, then that line's going to divide the two other sides into proportional sides. So we'll come to example number 1, and we'll use this concept. We see that we have a line. Okay? If a line is parallel to one side of a triangle, then it divides the other two sides proportionally. So we see that we have the parallel sides. If we have these parallel lines, then we know that the line must be dividing it proportionally. So we're going to get RQ over QU to equal RS over ST. The typical way we had to do this before is the small triangle over the big triangle, the small triangle over the big triangle. You could still solve it like that, but this is just another way you can write the proportion. So that's 10 over QU to equal 12 over 6. You might notice that cross multiplying would give you 60 equals 12 times QU, and by dividing by the 12, you might not be surprised that we get the answer of 5. If you look at your original proportion, if you divided by 2 to get to the 6, then you got to divide by 2 to get down to a 5. So we're not surprised that the answer is 5. But now we've mathematically shown that it's 5. That would have to be 5. We can also do it in the converse. We can go the other direction. If the sides are divided proportionally, then the lines are parallel. So we're supposed to be showing that these two lines are parallel. We look at the picture, they don't look too parallel, but let's see what happens. So we're going to divide the triangle so the sides are divided proportionally. So what we're trying to figure out, PQ over QR, is that equal? We don't know if it's equal. That's the question. Is it equal to PT over TS? So we can plug in the numbers. We have 18 over 38, and still we don't know if it's equal. That's the question. Is it equal to 36 over 80? There's two different ways we could do this. We could cross multiply, probably require a calculator, see if we get the same big two numbers. Or you could just reduce the fractions. Maybe reducing the fractions is easier. So what number goes into both 18 and 38? Come on. What two numbers go into 18 and 38? So 2 is going to go into both of them. So we get 9 and 19. And what two numbers go into these two? Okay, 4 goes into that guy 9 times. 4 goes into 80 20 times. So we do not have those equal. If sides are not divided proportionally, then lines are not parallel. We do not have proportional sides, therefore the lines are not parallel.